All right, I think we can start, and those who are a little bit late, they can join us later. Hello, everybody. My name is Valery Sidnikov. I'm CEO of Sevana, and I'll be making this webinar, holding this webinar today. From Sevana, we also have Dmitro Bogovich, who is our CTO. He's also present, and he will uh, assist me when necessary with, for example, with questions I cannot answer. Uh, I would like to ask you, please, if you have an immediate question, raise hand so we can see, and or use chat so I can check during the presentation. We also thought, how would we make this webinar, and decided that probably we try to keep it as a friendly conversation because the topic is quite specific, and I'm quite confident that all of you who joined this today are professionals and you know what it is all about. So basically, we would like to share our, well, first of all, what we are doing, of course, and our vision on importance of stressing quality of experience metrics together with quality of service for call quality analysis and monitoring. There are just 4 slides to describe what we are going to talk about, what we would like to talk about today. And then we switch to the online demo and show you how the things we do are actually working. It's very likely that most of you were attracted by the promise that we'll show what we do that the others don't. This is true. We're going to show this. And this is related particularly to quality of experience. So basically, 2 sets of metrics: quality of service and quality of experience. Quality of service, it's related to the data traffic, packet loss, latency, jitter, and to technologies that manages data traffic. Quality of experience, on the other hand, it's an overall customer satisfaction. And it's somehow related to quality of service, but not exactly the same, because we are particularly interested on how our customers, our callers, subscribers actually feel the quality. Are they happy or not with the quality we provide? So to measure these 2 metrics, we have metrics from packet switch network, packet loss, latency, jitter, RTT delay. And as a standard approach, we have ITU-T recommendation G107, also known as E-model. For quality of experience, we have different perceptual models. For audio analysis, one can analyze, for example, noise and predict quality of experience, the actual quality of the payload that is being delivered. And from ITU-T, we have standards P563 and P564, which are targeted to analyze audio. And P564, if I'm not mistaken, it's a Telchemy proprietary standard that expands E-model to with some audio analysis. So basically, what we do, we build a perceptual model that deals with known impairments like noise, audio gaps, clicks, amplitude clipping. And at the same time, we also detect other problems within the audio, like silent calls, echo, PAD clipping. Then we generate our own R factor, also a value up to 100% that represents how much of the call was of acceptable quality. And we convert it into a MOS score, which is a mean opinion score, the standard approach for subjective and objective voice and audio quality analysis, basically a value from 1 to 5. And another thing we do, we generate really big data related to audio quality analysis that can be used for pattern search and analysis. For example, one can discover inside the audio patterns related to packet loss or others. All right, so hopefully you will be able to see how we receive full details on quality of service, all the packet switch network metrics. We calculate e-model-based MOS, then receive details on quality of experience, how we calculate different audio impairments inside the audio, also audio problems detections throughout the whole call. Finally, how we generate the MOS score, and of course, how everything of all of this is done in real time. All right, I guess we can switch now to the demo itself. Sorry. So far, does anybody have any questions?
Yep, I had one question, wrote it in chat about VAD clipping. Just hearing this for first time. Can you elaborate a little bit, maybe, on that?
What in particular, VIT?
It was a point about VAD clipping.
Oh, VAD clipping. Yes. This is related to delays of voice activity detector, and typically they are represented as gaps in audio when audio is being processed. Well, it provides delays, if I'm not mistaken. I'm not the main guy in technical matters.
Sorry, sometimes voice activity detector is not perfect. It can cut extra audio easily.
What was this answer sufficient?
Yeah, thanks. Yeah.
Okay. I'm sorry, Dmitry will naturally have to help me because, as I said, I'm not the smartest guy. All right. I hope you can see my screen well. And I should say that we are not trying to substitute existing call quality monitoring systems. What we are trying to do is to provide additional functionality and additional metrics related to quality of experience. And this is actually what we do, and how we do it. Exactly how we do it, I don't know any other company or entity. So here we have some, well, this is a simulated environment. There is a PBX. There are end-to-end actual test probes, which we also have in our portfolio. And these probes are making test calls with different duration. Some of them have problems inside the audio to show you that these MOS scores, which we call Sevana MOS and network MOS, they may vary, not necessarily being the same, like here, for example. And this is actually what we like to stress, that in real environment, this also happens when network conditions are fine, although there may be problems with actual audio inside the network conditions. As an example, audio coming to your network from another network, for example, mobile network, that got some gaps, or if it is VoLTE, it might have got packet loss. So your network, your voice over IP network, receives audio already with problems, but you cannot track it because your network is fine. There is no packet loss, no delay, nothing that can affect it. But your clients may still complain. So there are test calls being made, and the server is running on the same server. Our monitoring server is running on the same server as the PBX. So it captures streams by stream capture. And then it parses the streams, calculates all the metrics, takes the audio out, sends it to analysis, and then calculates different or both metrics related to quality of service, like network MOS is based on, and quality of experience. And this is what Sevana MOS is based on. Of course, all the metrics, all the other parameters like source and destination, jitter, we also parse SIP. They are detected and stored in the database as well. Now, let's take a look at the perfect call. Well, this call is still running, so it's not finished. Not all the metrics might have been calculated. From quality of experience and network side, we calculate all these. All these parameters, like we detect and store SSRC. We calculate network MOS, jitter, RTT delay. In this particular example, it is not calculated. We detect what codec type, packet loss. As this system is already used in some mobile operators, we are supporting wide range of codecs. And for AMR, we calculate switch counter as well. And Sevana R factor, SIP metrics, for example, destination and SIP source. And this part is related to actually quality of experience. This part, detector counters, this is information we receive from the actual audio inside the stream. So this shows how many times issues related to certain impairment, like amplitude clipping or dead air. This is different types. This corresponds to audio gaps that may be specific for packet loss without error correction, or noise or echo, how many times they happen during the call. The call itself is split into 10 seconds for analysis, and for each 10 seconds we deliver information on network conditions and network MOS score and audio conditions and Sevana MOS. So every 10 seconds one can receive report on comparing network conditions and audio conditions. So we can see here it was pretty much a perfect call, and only in the very beginning there were some issues. Well, that still is, probably still ongoing. And this is the big data I was referring to. We create after audio analysis. So here we can see that in the very beginning there was an issue with the so-called dead air type 01. This was an audio gap which happened between 1.3 and 2 seconds of the call audio. So behind all of this, behind these numbers, which one may consider some kind of probability of facing certain impairment on the call audio chunk, there is a perceptual model. So if we're talking about SNR, which is signal to noise ratio, this is not exactly, or not just calculating signal to noise ratio, but there are different thresholds that kind of tune the algorithm to trigger only when we consider that noise level, noise conditions influence the call quality and user perception, or caller perception. It's like with echo, for example. We know that echo with less than 50 milliseconds delay does not affect human perception. So if echo is present, the algorithm is configured typically by default not to consider echo with delay less than 50 seconds, then the echo impairment will not be triggered throughout the call. However, if we look at some stored calls, stored metrics, and some calls with, well, as you can see, they're typically more scores related to audio quality and network quality are at least close. There may be some audio gaps or some other impairments providing minor influence to the audio quality and human perception of this audio. But we also play some calls with audio containing different impairments, and you can see that there is exactly a situation when we have network conditions perfect for this codec, and audio conditions seem having problems. All this information one can receive also in real time, but if we check the pre-recorded call, we have full details on the call, what happened there. So we have all these metrics. As we can see, there were no lost packets. There were certain audio quality impairments, audio gaps, and even silent call. I also mentioned on one of those slides that we collect different impairments. For example, the silent call detection type of detector was introduced particularly for one mobile operator that was experiencing silent calls in their network, and they wanted to detect it. So all of this is configurable, and I don't want to dig into details of the algorithms, which you are always welcome to email and ask me or Dmitro. And okay, this call lasted less than had issues. So we open the first 10 seconds of the call report, and we can see, okay, the main problem was in audio gaps. Audio gaps were happening throughout the first 10 seconds, pretty much all the time. And if we open the other 2 seconds, again, audio gaps. These audio gaps means when speech is interrupted with absolute silence. I'm sure you heard this type of impairment when there is a packet loss without error correction, and the gaps, the zero level signal, audio signal, is not filled with natural noise, for example. I know that there are more representative audio or calls here. Let's see. Yeah, this is a good one. Also, of course, we simulated the audio inside the call already has these audio impairments, but the system immediately shows, for example, high presence of impairment, click, echo, noise, and even silent call, and of course, audio gaps. And when I was talking about generating this big data for further analysis of feature of certain destinations or originations or a piece of traffic, this is exactly what can be analyzed because, for example, our tests show if clicking impairment is present together with this type, dead air type 01, the gap, audio gap impairment, it's very likely that packet loss type of a pattern is present in the audio. So in terms of voice over IP network, we can say that it's very likely we have received this call from another packet switch network that had packet loss. Echo was also detected and noise, and we can see how it is represented in the call statistics. So it was quite a long call, around the 44 seconds. So for each 10 seconds, we have all these MOS scores, and we can see, all right, well, which is the lowest. You can see that some parts of the call were just fine. Right, let's take this one, see what was the problem there. These 10 seconds are also split into audio chunks, each of 680 milliseconds, if I'm not mistaken. This is an empirical number, doesn't have any meaning, but the good part here is that we can actually pinpoint which part of the call was affected at which time by certain impairment. So we can see that, okay, here it was silence. Silence was present here, so probably there was no speech, but very likely even the natural noise level was quite low. And here, audio gaps were detected, and this means that, all right, there was some signal activity that was continued with an absolute silence. No other problems in this part of the call, but I remember there was some echo, right? Echo didn't take place at this part of the call. Sorry, I don't know by heart when echo took place, but probably it's also good for the demonstration. All right, here it is. So echo started at second 93 of the call and lasted to second 90, 97, 98. Again, was the echo was detected. This was marked as poor quality audio chunks of the call. And after all, the statistics for impairment detector counters, statistics for network parameters were calculated and stored. Let me make a pause here in case you have any questions so far.
Hi, yeah, my name is Fabian. I was chatting here with a couple of guys. I have a question about the hardware-based tabs, because I think that a customer would prefer not to install any application on their PBX or switch and have something external to the actual soft switches to actually capture the packets, because some of them don't even allow access to install any package on them. So what type of a hardware-based type, if any, you use for your customer real life scenarios?
Oh, yeah, absolutely. Sure. We have different ways of capturing packets. Port mirroring is one option, of course. So this system, this server is located somewhere aside, and the traffic is mirrored to it. And here we already have a lot of options for optimization, because if you have huge volumes of traffic you would like to monitor and analyze the quality part, audio and network, you can mirror a percentage of the traffic. You can analyze certain parts of the call, for example, last 15 seconds of the call, and this will give you information about short calls, reasons for short call termination. So, of course, there are all different options to send traffic to this system.
Okay, and do you also suggest your customer to set up some configuration parameters on their network equipment to make sure that the void packet has priority and don't get dropped when there are too many packets
That's very
VM?
depends on network. Some network can recognize cause bits, some not. Can give general answer, common answer.
Okay, have you made any like test to know how many streams or voice in simultaneous voice you can accurately process and calculate metrics for? What is your biggest, let's say, analysis on any customer, like 1,000 simultaneous calls of different type of code combination? Do you have any metrics on that to see the capacity or the level of actual code processing that you can make in real time?
VPS on at Amazon Cloud can analyze up to 800 calls. Yes, 800 calls on, I think it was 16 core VPS, virtual private server. It's full load. It's analyzing of all detectors, analyzing of all call, all duration of call. It can be optimized. We can analyze, for example, only tail of calls last 10, 15 seconds. It's the time when most probably problems happens when call ends. We can analyze for subset of detectors. It saves performance as well. We can analyze some percent of calls.
Yeah, you decide like get a sample, have an idea of the whole situation. That's cool. Can you also, let's say, did you know you want to make a call based on the calling number or destination number or any other parameter? Can you set a tab or a trace for that specific call at any moment, at any time? Like a schedule type of trace for analyze a specific call that is going to be made in the future?
We can do it, but it's custom logic. It's every customer has their own requirement, and it's done in every case in different ways. We
Well,
help with this,
so,
yes, no problem.
To be honest, I remember we had discussion to dig into particular SIP number and analyze it, right? So technically, it's possible. And I would like to add about the performance, because it is very flexible. If you know, for example, that your system is pretty much packet loss free, then we can turn detecting these audio gaps. This will save on performance. If you think that, okay, at this point, we don't want to analyze the quality of experience, we don't want to analyze the audio, we want to analyze only network, then we are talking about 10,000 simultaneous streams or even more, because the system can be scaled both vertically and horizontally. And if there are no other questions at this point, I would like to continue how it can be used to analyze call quality online, not in real time.
I have one last question. Do you also work with a secure RTP, like RTP that is encrypted, and also with a signaling over TLS, where I guess you need some sort of a key to access or decrypt the packets?
In this case, we calculate only network MOS. We can't decode as RTP.
Unless we have access to it, right?
Yeah.
To case, of course.
Yeah, as I promised, it's a friendly conversation. So please, if you have other questions, go on. All right, then I will continue with another part. So the whole thing, the system is built on a real-time RTP analysis library. Therefore, like I said, in case you like to monitor only network MOS, e-model MOS, and particular calls you like to record as a pickup file, there is a functionality for, I call it online analysis. Real time is real time. This means that every 10 seconds you can receive information about the call, all the metrics. You could see, for example, well, these are ongoing calls, but all the metrics you see here, you can receive them every 10 seconds. And of course, for integration, there is JSON reports. There is also alerting, so you can set thresholds for MOS scores, thresholds for, I don't know, jitter, for example, or packet loss. But at the same time, if you like to analyze something what you recorded as a pickup file, you don't need real time. Even with this server, it is possible. We have G729 codec pickup recording. Of course, we prepared it in advance, but this is taken from one of our customers, most likely mobile operator, I believe. And here it is. All the streams will be analyzed, and you have the stats. You have also these MOS scores calculated, and you have all the reports actually for all the streams in the pickup file. Yeah, with all the metrics for every audio chunk. So for this purpose, for the purpose of pickup analysis, because we also have customers that actually prefer analyzing huge number of recordings or call recordings, and they don't need any analysis of packet switch network. It's not present. But we also have customers that capture calls. For example, their system can capture calls itself and record it as a pickup file. We have a partner that has a box that captures a huge amount of traffic as pickup in real time. And in this case, one can use a little utility that will convert pickup recordings into this kind of report in JSON format. Yeah, like here, for example. Of course, it can be accessed. We also have, these are telco customers, and through one of our partners, we have a customer for this kind of analysis, satellite operator. They, our partner, they have a quality monitoring system, full scale, and they use this just for a part of the call. So they record 15 seconds, last 15 seconds of the call as a pickup and send it for analysis. On the other hand, of course, we have to follow regulations. So this system has a feature of recording calls as pickup. But of course, the main functionality is that the system parses RTP traffic, grabs the audio into memory, analyzes audio, and destroys the memory. So nothing is stored. There is no tapping of the speech. Everything is done in real time, and just results are stored. Finally, I don't know, I think this may be a good point before we go to real questions and answer session. There are some reports. We don't emphasize neither graphical user interface much, to be honest, nor the reporting, because these reports are generally customized. Some customers are happy with the reports as they are. Some customers would like to have more. But just to show you that some reports are present, and of course, they can be easily generated. As you can see, 3-month report. I think this is one mobile operator. Custom reports or even comparing reports is possible. So we have R factor. This is our R factor, Sevana R factor audio related graph. Then delay, call duration changes, jitter changes, network MOS or E-model MOS changes, and Sevana MOS. As you can see, at this point, it seems that the server was down or just switched off. Okay, I see that Dmitry tells me that there is a question from Alexander, right? Gentlemen, if anybody has a question, please go on.
I guess I had a question, but someone already asked it, so it's
right.
it's being deprecated. Sorry.
I'm sorry. Dmitry messaged me. I told him, please message me.
Yes, okay, that's great. That's yes, you're the chief. Okay.
All right. Great. So this is in general. This, like I said, this is available as a library, and we believe it is quite flexible to have it integrated. And of course, if you at a certain point decide you didn't ask any question you wanted to ask, just send me a message. Maybe some more questions. Maybe I missed something. Maybe you like to learn how a particular case can be solved with what we are doing.
Yeah, maybe I would like to ask a bit more about echo detection. Do you have like some specific thresholds for it?
Yes, there are threshold. It's configurable.
I don't
There,
really. No,
okay.
yeah, I was just in general interested if there are thresholds and if it is configured. And yeah, okay.
Yes, it is. 50 milliseconds is a standard threshold.
I meant volume threshold.
Volume. Volume. Yeah, how much echo is present? Yes, we do, of course. So if it is a minor echo, happening for several milliseconds, or I don't remember by heart the thresholds, but they are available.
Okay, thanks.
Some other questions, perhaps?
Okay, maybe me. So can you elaborate a little bit more on network MOS, how you get it? Because I missed it a little bit.
Metro, would you like to cover this question?
Sorry, Valeria, I was in the chat with Maxim
Okay.
answering the question. Please repeat, sorry.
Yeah, it's good to keep us busy. How we calculate network MOS? This is the question.
It depends on packet loss and packet distribution over the time. I don't remember a formula, but it's close to used in YP monitor one. I think they do in the same way.
Okay, so network MOS is based on network parameters like jitter and
Yes.
the packet loss, and
Yes.
Sevana MOS is on call quality parameter, let's say this way. Okay, thank you.
On
It's
audio
clear.
quality.
Audio quality, yes, audio quality.
Also, question about network MOS. I heard, but I never researched myself about these probes over network. Is it like some sort of software which will send some data to you, like about packet loss, about bandwidth? Like how are actually those probes? Are they like? Is it like physical device or just like software?
In fact, the traffic is generated by our own probes. They are part of another system, end-to-end quality monitoring. These are purely software probes, cross-platform. This is a tiny application, actually, with the capability of making calls, playing audio, receiving calls, recording audio, doing all the analysis, and actually even pushing analysis results to the backend of your choice. So these are our probes. They are some kind of soft phone, maybe.
So I guess it's sounds for me that it's not just probe, but with functionality of like making a call and sending audio.
Oh yes, then record the audio, answer the call. It is more like a soft phone.
Yeah, okay. So which also acts as a probe for network, like to send the condition of a network to when you use it to make the network MOS.
We don't simulate packet loss, although we could. Actually, all the calculations that we take the traffic and then calculate packet loss, jitter, latency from the traffic. Then put it into the formula of E-model or similar and calculate network MOS.
Okay.
what we really simulate here is something happening to the audio. So the network is quite stable this time.
Maybe about technology. Do you see like recently there might be coming any new like technologies, any new advancements which you are looking into implementing in your system? Like what's overall in industry happening?
Well, to my knowledge, we still have globally we have P563 and P564, and they actually the P564, if I'm not mistaken, it's an advanced e-model. I don't remember exactly. It's a patented technology, and description is available on ITUT website. But so far, something similar, probably not. I don't know. The trends, I don't know. I have to think if I may announce this. Probably not, but we might get some deeper access to the current trends. But I know one company in Germany that is doing something similar, but they only calculate, for example, amplitude clipping, presence, detect echo, that kind of analysis. We're trying to generalize it and to predict a MOS score that can be comparable with network conditions, e-model MOS score. The trend, I would say, I see, and this is also the reason for this webinar. It seems the technology is demanded because there are companies that have lots of call recordings. They would like to sort according to and clusterize according to the audio quality. There are issues in call centers that service providers would like to identify whether they were caused by the audio quality coming from the operator or the problems with their conference bridge, for example. Silent calls. Maybe you also have this kind of issues related to silent calls when there is no audio present in the call and you would like to detect this. So we see this as a trending demand for such technology. It is easier to speak about trends in end-to-end analysis, audio quality analysis, to other ITUT standards like PESC and Polka, because I know that it was under cooperation of Google and one Irish university, I believe. They developed a similar alternative technology for end-to-end analysis when reference audio is compared with the test audio. In this case, we don't have reference audio. So I hope, yeah, please go ahead.
Thanks. Maybe if I may, one more quick, do you have how it is weighted to get the Sevana MOS? Is like what is prioritized? Like, is it echo is weighted for more or like distortions or like pretty equally between different metrics?
Oh, this is actually a very difficult question to answer because this is related to the perceptual model. Of course, there are weights, but the whole model configuration, it's available. It's in the text file. It's in a config file. But the question is very complicated, and I can explain you why. So we have, for example, that we have 10 seconds of a call. If we have even one fraction, well, I don't know, 100 milliseconds of echo for 10 seconds of the call, it is not a big deal, right? Or we have clicks or we have noise lasting a fraction of a second. For a 10-second part of the call, it is not a big deal. So the perceptual model we have, it actually detects impairments, and then it detects all impairments on the time slot. I'll show you. This 680 milliseconds. So 10 seconds of call are split into these audio chunks. So the algorithm detects all impairments, and then for this particular 680 milliseconds, we analyze how frequently impairment was taking place, what was signal noise level, how many clicks were detected. And based on this, we generate these numbers, which one may consider some kind of probability. It's not exactly probability, but something similar to make the things simple, you know. So I don't have a full, complete answer to your question because it is quite complicated. Some more questions or test cases. I wonder. I believe you might have something to contribute as well. What we could analyze, work with, answer.
Nix.
Oh, yeah, go ahead.
Okay.
I was going to ask if your solution can be used in an environment like Amazon Cloud or Google Cloud or Azure, where they actually limit you to access the underlying network infrastructure. You don't have actually access unless you have your application installed in the same server. Aside from that, is there any other way that you can use your technology to capture the actual voice packets traveling on the VPS or whatever and do your analysis?
I think I tested on VPS in Amazon Cloud. Worked without any problems.
We claim we have very flexible products. So from different perspectives, licensing can be flexible, so it can work in a container, in the cloud. Should not be a problem. All our tests, I mean, our stress tests were made in Amazon, I believe.
Okay.
Sorry, Nix, I think you raised the hand. Okay.
All right. Maybe, yeah. What I did not mention are some real cases or real use cases for this kind of analysis. Of course, I already said about silent calls. This is one. We also had a case for amplitude clipping detection. So the calls from certain origination were experiencing amplitude clipping on a regular basis. This was detected, and then the maintenance team went through the leg of the call and actually discovered a voice gateway that was providing additional amplification which caused amplitude clipping. Then it was quite interesting. One case when to improve the performance, our partner was analyzing only 15 or 20 seconds of the call last, because thus they wanted to find reasons for short calls. But apparently echo was appearing still in the very beginning of the first 15 seconds. So they had to analyze both. But well, unfortunately, I don't know the full story, but I believe that this was detected and finally fixed. Audio gaps, I already talked a lot about them. Question? No? We are pretty much done, I believe, describing the system, because my whole idea was to, stress and emphasize that we consider quality of experience and audio analysis for quality of experience being quite important, together with network metrics analysis. Well, please interrupt me if you get a question. What I would like to say, if there is interest, we also wanted to talk, to make webinars about end-to-end testing and how to implement it very quickly. We also have this end-to-end testing. It's available both for mobile networks and VoIP networks. So basically, we wanted to show how easily one can actually set up mobile-to-mobile testing, or even messenger-to-messenger over mobile network testing. We are currently working on video quality analysis, particularly for mobile networks. So if you all received invitation from me today, if you have any wish, or you would like to learn about anything, what we are doing in more details, or you have a particular case you like to find a solution, you are very welcome to send me a message. If you forgot to ask a question or figure something out, I'll gladly set up one-to-one session, and we can analyze in particular your network topology, your case, and we can think together if and how this audio quality analysis can help in your particular case.
I would like to ask a maybe quickly general question. Are you taking a part, maybe just as a guest or as a lecturers in any conferences across the world?
Well, we were attending Mobile World Congress 2 years in a row before COVID. And this was pretty much our main activity. Then we were thinking where we could go and what markets, because these days our customers come as from Europe as well as from the United States, and we experience interest from Japan, for example. But figuring out a particular event that would be useful or may be useful, it was quite a challenge for us. We didn't find it before COVID. So the answer is no, not yet. Probably we should. We got an invitation to one organization before before everything is set. I don't want to disclose this. Maybe it's not appropriate. That is working closely with such questions and such topics as quality of service, quality of experience. And if everything works fine, then will gladly join them. If you think you can benefit, we'll be happy to provide materials or join your events.
Okay, thanks.
I see we expected about 25, 30 people today, and that's why I booked 2 hours just in case. But I see we are doing very well. Just 1 hour passed, and seems we're done. Please, if you have questions or you like to share something, or I don't know, I hope all of you received my contacts. Metro, any raised hands?
Maybe one question also about reporting, like to the customer. Would you usually just will the customer see the reports for themselves? They will have like this portal or something, or you will be sending like report with graphs and with an analysis?
We have at least one mobile operator that is using this system as it is, and at least some of the reports was prepared specifically for them in order to fit the governmental requirements for reporting on quality. In many other cases, our clients are solution providers or service providers that already have their own system, and they like the ability to integrate into this system and take the data, whether as a JSON report from these links, and I'm sorry, I don't remember the interface name, or directly from the database, and actually integrate them into their own reports, because we don't deal with CDRs, we don't deal with other call metrics, and typically many already do this. Many or most already have some call quality analysis and monitoring system. So it is possible. It is possible to, for example, pull the data for your graphical report, and then from the system, and you just represent it in your system or somewhere. It is possible. Okay. Maybe you can, some of you can share your vision. Actually, does it make sense to you? Is it worth working in such? We think it is, but maybe network MOS and e-model MOS is pretty much enough these days. And we know that there are many systems that using just this metric and all the packet switch network metrics. So counter arguments are also welcome. It's a friendly discussion. Okay. If you like to get access to the system, please email me and we send you the link and you can play with the system yourself. In fact, you can even send traffic to it. Not necessarily it will reply with something, but we can give you also numbers you can use to call and see your call quality reports represented.
Are you going to provide that information to everybody in this chat, or we have to ask for it?
Actually, both options are possible. The numbers to call, I don't know them. Dmitro, do you know them by heart?
Yes, I can provide numbers.
And actually, the system is not hidden. It is available freely on the net. So here is the direct link. However, what may happen is that if there are too many people trying to access it, it will crash because it is really just a demo system.
Yeah, I understand.
We have on Google Play, we have Qualtest application, which makes Qualtest or Sevana Qualtest, which makes mobile tests, but SIP calls. So you can make a call from that system. I believe you will see the result in this system. Am I right, Dmitro?
Yes.
You can also make a test call to any other SIP number using mobile application, or if you like, we can also, but okay, this is better one-on-one. We can give you these test probes we're using. We can give you all the tools for your evaluation, so you can play with pickup recordings you have. You can set up these test probes for end-to-end testing. So we're very open to share our tools with you. I have a question to you all, gentlemen. Well, first of all, of course, I should say thank you very much. It was a great pleasure to find out that so many people may be interested to see what we are doing and to join this event. And this actually gives us power to make more events like this. So currently we have two options for the next webinar. One is mobile to mobile end-to-end call quality monitoring and testing. This means you take a real mobile phone, rooted or non-rooted, and set up a test from one mobile to another mobile, or making a Skype call from one mobile to another mobile over mobile network. So we can tell you how this can be made easy with the help of what we have developed. We also have customers for this system. Or we can also talk about end-to-end testing, which mobile part is just a part of it, actually. So the overall end-to-end monitoring system is working seamlessly both for mobile networks and VoIP networks, because we have mobile probes and VoIP probes. So either of this, we plan to make a topic for the next event.
Those are very cool. Are you going to provide, how do we know when the next event is going to happen? We can follow you in LinkedIn or something, or Facebook?
Oh, sure. You all subscribed in MailChimp this event, so we have your email addresses. The only thing is to receive your permission to use your address to inform you. And we can use them to inform about the new event. I think it will take another month or so, maybe several weeks. So I can just email you or Olga. Both mobile and okay. Well, first mobile E2E. Okay. All right. You know, we can join probably. Dmitro, what do you think? Can we join mobile part and VoIP part within one webinar?
Yes, it's very logical. It's the same system, in fact.
Yeah, it's the same system, but two cases. So because actually we wanted, to show you, because I told Dmitro, we have to show the people. We have to take the phone. We have to connect the phone to the computer or Raspberry Pi and show that it actually works and make the test. Take another phone, connect, make the test. Probably we can also show how we install the VoIP probes, but these are SSH access, very simple. All right, so if you don't mind, we use your email addresses to notify you about the next event, which will join Volti-Sounds. Volti-Sounds very interesting. Okay, great. Okay, then we made the decision. I think it will be Qualtest solution that unites VoIP testing. Yeah, thank you, Fabian. I see your permission to use your email. So it will be Qualtest solution, VoIP, end-to-end testing, and mobile, Volti in particular. Thank you, Alexander. Received your permission as well. So Volti tests, and in fact, we ran 5G tests as well. 5G network is available in Finland, and my friend, because the traveling is limited or was limited, my friend made tests in Helsinki using our 5G phone. So we can now say that it works seamlessly. Oh, Dmitro, by the way, we can also show tests on 3G network, then switch it to 4G.
Yes.
Yeah, all right, great. Thank you very much for your contribution. Now we know better what to come up with for the next event. Any suggestions for the next event? I don't know if you like how it goes. Are you happy with Google Meet? I guess you are.
I think yeah. So first of all, thank you for making this, and definitely I will be really looking forward to take part in the next ones. So thanks for this. And regarding feedback, maybe for me it was a rather quick the way you went over environment. Let's say about like setup. Maybe it could be a bit more elaboration. I know like. Because there might be different levels of understanding for people. That way also, like it will be. No, presentation will be also a bit longer maybe, but yeah, I think some general information about environment setup and some metrics, and just to talk longer in those slides will be better.
Right. Well, if you like, we can set up a separate meeting with you, so we discuss in particular how to install everything, how to roll it out, how to configure.
Okay, all right.
Okay, great. Thank you. All right. Seems that we are pretty much done.
Okay, Barry, this is Jose. I really appreciate your support. I think that is a good experience. I would like to continue learning something more about that and working with telecommunication. I would like to be in the next event that you have. Thank you.
Thank you very much, Jose. We'll definitely notify you.
Also, can you share the slides that you presented here in the attachment section of the meeting?
Pardon, I didn't.
Can you share the slides that you talk about in the meeting?
Oh yeah, sure. Actually, we would like also to upload the recording of this event somewhere to YouTube, for example, and we share a link. And the slides, yeah, I'm not sure if I can attach them to this meeting so that everybody receives. Yeah, but I will place them somewhere on Google Drive and share with everyone.
All right. Thank you.
Appreciate it.
Okay, then, gentlemen, let me again thank you very much for your interest, for your very friendly company today. It was great meeting you all. Well, I hope maybe next event I'll show up as well, so we can look face to face. And again, thank you very much for your time. Really appreciate that your interest to what we are doing gives us energy. So I hope you will enjoy the other event as well. Thank you. If no more questions, then I'm wishing you a very nice rest of the day. And let's stay in touch.
All right.
Yes.
Thank you.
Thank you
Have a
very
great
much.
day.
Yes, thank you.
Everybody have a good day.
Thank you.
Thank you. Bye.
Bye-bye.
Goodbye. Goodbye, everyone.
Yeah, thanks for preparing it. Bye.